Okay, so this is our lesson for Monday where I'll be away. You will recall maybe last Wednesday we started looking at the surface area of pyramids, and I said we'd revisit this today. So if you're in the Unit 15 book for surface area, Lesson 5, surface area of pyramids, if you haven't already got the notes that I'm scrolling through right now, then they're on OneNote. Obviously, we did that on Wednesday if you were away. We didn't do, however, example 3 and example 4, which I'd like to run through with you now, and then you guys will have some work to do as well. So for example 3, we've been asked to find the surface area of a regular tetrahedron, which is just a pyramid that's got all of the shapes that make up that pyramid are equilateral triangles. So we got 3 equilateral triangles moving up to the base, and then we got one up to the point, and then we got 1 equilateral triangle on the base. So in order to work out the surface area, we're going to need to be able to find the area of a triangle. So we can almost forget the method for going about a pyramid here, because we've essentially got 4 triangles. They're all the same size. So if we find the area of one triangle, we just need to multiply whatever that is by 4, and we'll have the area of all the triangles. So if we just imagine here I've brought myself the wrong pen. Here we go. We'll try that one. If we just imagine here just one face of that shape that has all 4 sides equal, that's all size 4. Because it's an equilateral triangle, remember any isosceles or equilateral triangle, if we split up 2 equal sides down the middle, so if we run a line through down here and we split it in half, we're going to get ourselves a right angle on the base. So once we do that, we realize obviously that means this little spot down here must be half of 4, so that's going to be 2. And so we can use Pythagoras to work out the height of that triangle. So for that, we're just going to use the standard a squared equals c squared minus b squared. And in this case, that's going to be 4 squared minus 2 squared. Now 4 squared is 16, 2 squared is 4, 16 minus 4 is going to give us 12. So a is the square root of 12. And I want you guys to get comfortable. We're going to do a bit more surds later in the year, and I know you've done them before. I want you to get comfortable with using surds. Now, 12, one set of factors of 12 is 4 and 3, and 4, of course, is a square number. So the square root of 12 is the same as the square root of 4 times 3, because 12 is 4 times 3, but 4 is a square number, so we can take it out of the surd. We can take the square root of it. The square root of 4 is 2, and that just leaves us with 2 root 3. So 2 root 3 is the height of the triangle. The advantage of not calculating now is that we can keep it more exact. So now if we think about the area of our triangle, area of any triangle is half base times height. So if the area is half base times height, then what we've actually got is a half of the base, which is 4, times the height, which is 2 root 3. So a half of 4 is 2, 2 times 2 is 4, so we're going to end up with 4 root 3 is the area of the triangle. Obviously that's going to be in centimetres squared. So now, because that pyramid is made up of 4 equal sized triangles, the surface area is just 4 times by the area of one of those triangles, which we've already just worked out. So the surface area is just going to be 4 lots of 4 root 3. And so that's going to be 16 root 3. Now you can at that point put it in your calculator, but I think probably with this question we could leave that as is, but obviously bearing in mind that it is still in centimetres squared, so we do need to put our units there. More and more, I'd like you guys to get comfortable with the idea of leaving things in exact form. So that includes, we'll do some of this stuff when we do circles and cones and pyramids and that sort of stuff, maybe leaving, rather than calculating pi, we'll leave things as 10 times pi or something like that. So 16 root 3 centimetres squared is even better than putting in the calculator because it's exact. Obviously, if the question had asked us to give it to so many decimal places or to the nearest square centimetre, then we would then put it in the calculator. All right, so moving on to example 4, we've got a square pyramid's surface area is 576 centimetres squared, and it has a base edge of 12 centimetres. And then we need to find the perpendicular height of one of the triangular faces and the perpendicular height of the pyramid. And the best way to sort of attack this is just to sort of look at it and go, well, if we know the surface area, how would we have found the surface area? If this is the bit of information here that we're given at the start, then let's think about that for a second. Well, what would the surface area of a square pyramid be? It would be the square. And being a square as a base, it's a four-sided shape, so there'll be four triangles. But being a square pyramid, those four triangles are all going to be equal in size. So four triangles that are all the same size. So if we then substitute what we know into that, so we know the surface area is 576, and we know that the square has an edge of 12 centimeters. So that means the area of the square is 12 squared, and 12 squared is 144. So that gives us our area of our square. Obviously, we don't know what the area of the triangles is. I'm going to use the capital T to represent triangles rather than writing triangles each time. Just a little bit of algebra going on here. So obviously, we do have a bit of algebra going on here. If I want to find out what the area of one triangle is, I need to get that T on its own. So first things first is I'm going to take away 144 from both sides, because that's going to get me just the four triangles on their own. And when I do that, that's going to be 432 equals 4t. And then, of course, in order to get the t on its own, what's happening? What's that 4 doing to the t? It's multiplying it, so we do the opposite, and it's to divide. So we just divide both of those, and we're going to end up with 108 equals t. So that means the area of our triangle is 108. So we've sort of worked backwards from the surface area, and now we know the area of the triangle, but we actually want to find the height of the triangle. So let's think about that. The area of a triangle is just a half the base times the height. Now, we already know what the area of this triangle is. We know it's 108. And we know what a half is. That's just a number. And the base is 12 because the sides of the square on the base are going to be the base of every triangle. What we don't know is the height, but that's okay. We can work that out. So 108 is going to equal a half of 12 is just 6, so equals 6h. Once again, we're doing a little bit of algebra here, and we divide both sides by 6 to find out what h is. And when we do that, h equals, and I have it written over here, that 18. Okay, so once we know, and that's the answer to part A. So therefore, height, what's it given? K equals 18 centimeters. Not squared, not cubed. We're after a distance. So we've worked back from an area to a distance. So that's ticked off part A there. We know now what the height of the triangular face is. So we can say this here is 18. Now, that being the case, we've now got ourselves a right angle triangle here with one side h, one side 18, and one side's going to be 6, because it's half of 12. So we've got a distance of 6 there. So we can use a bit of Pythagoras to find out what that last remaining side is, and therefore answer part B. So I'll do that in blue. So what we're going to start with there is the formula a squared equals c squared minus b squared. And then we just substitute in the values that we have. Now, a in this case is named h, so we'll change that around. C squared is going to be 18 squared, and obviously the base of that little right angle triangle in the middle of the pyramid is only going to be half the base of the pyramid, so it's going to be 6 long, and 6 squared is 6 squared goes in there. So we end up with 324 minus 36, which is going to give us a final number of 288, which of course we then have to take the square root of to find what h is. Now, we could look at simplifying that as a surd, but given that the question here asked us to answer correct to the nearest centimetre, they didn't actually, if we leave it as a surd, that's not going to be as correct. So we'll take the square root of 288, and that's going to give us 16.97056. I'll just keep going. But in our case, well, that's the most ugly approximately equals to sign I think I've ever drawn. We use the wavy lines to say approximately equal to 17 centimetres because it asks to the nearest centimetre. And that's how you do those ones. So going on from there, what I want you guys to do today, obviously down here at the bottom is the questions I set you. You can spend a little bit of time on question 3, but drawing nets is not really where I want you guys doing. So make sure you get 5, 10, and 15 finished. A lot of you got a fair way through that last week. So I have put here into OneNote a little tab called Extra Pyramids for this lesson. So if you go into there, what I'd like you to do is the questions I've highlighted, which is exercise 403, question 2, question 3, question 5, and question 7. So I'll just drop back into the lesson and I'll write that there next to that so you can follow. So, once again, need the right pen. Extra pyramids. And I want you to do, what was that again? Was that 2, 3, 5, 7? Sorry. One should be more prepared when they're doing a video, shouldn't they? 2, 3, 5, 7. I was right. Questions 2, 3, 5, 7. Now, because I'm away, the only way I can really run this and make sure things happen is that I can guarantee you a bit of lunchtime maths if you haven't had a good attempt at those. And a good attempt means getting a good amount done and getting it done with logical setting out. I don't want just answers. The back of the book has just answers, and that doesn't interest me. So your notes in your theory sheet need to be up to date with this lesson, having added all that in there, and you need to have had a go and finished the questions from exercise 1F of your textbook, and then had a good solid go at some of those extra pyramids. And I'll be checking up on that later in the week. See you then.